we are now going to graph higher order polynomial functions. So here's our example. We have f of x equals x cubed plus 5x squared minus 4x minus 20. Please take your time on writing this example down. Write everything down. You will see some problems like this in your homework. So the first thing you want to do is identify the degree. The degree comes from this number 3. It's the highest term's power. So the degree is 3. What the degree 3 tells us is the shape of the graph. Since it's a degree of 3, an odd degree, the shape is going to look like a snake, or if you also call it an S. You can write either one. The behavior of the graph, that end behavior. The leading coefficient of this polynomial is a positive number, and the degree is 3. So if you remember back to end behavior for our chart, that leading coefficient test, what happens is it's going to rise on the right, and fall on the left. So my graph's going to look something like this. The polynomial, the naming of the polynomial, is, since the degree is 3, it's called a cubic function. And then you can count how many terms there are. 1, 2, 3, 4 terms. It's a cubic polynomial with 4 terms. So there's my part A. Now I want to go out and find the x-intercepts. The x-intercepts are where they touch on the x-axis. So we want to find the zeros of the function. So I'm going to set the function equal to 0. I'm going to find out what the x's are. So I'm going to be using some factoring. So since I have 4 terms, I'm going to do grouping method. I'm going to group the first 2 terms together and the next 2 terms together. I'm going to take out their GCFs. So the GCF of the first group is x squared. I'm left with x plus 5. The GCF of the second group is negative 4. Left with x plus 5. Now the new GCF is my parentheses, x plus 5. And my leftovers are x squared minus 4. Now I'm going to set those factors equal to 0 and solve for x. So here's my first factor. X plus 5 equals 0. I'm going to subtract 5 from both sides. So now my order pair is negative 5, 0. The second factor is x squared minus 4. So we set that equal to 0 and we solve for x. So I'm going to add 4, and then I'm going to square root both sides. So I get plus or minus 2. So I have 2 x-intercepts there. I have negative 2, 0 and positive 2, 0. All right, going on to part C, the y-intercept. To find the y-intercept, it is the c, the constant of the polynomial. So if we come back up here, the c is negative 20. So identify that as over 0, down 20. Now we're going to go ahead and graph the things that we found so far. So since I had a pretty big y-intercept, I'm going to change my axes on the y to a scale by 2. So this would represent 4, 8, 12, 16, 20. And then negative 4, negative 8, negative 12, negative 16, negative 20. And I'm going to create that y-intercept of 0, negative 20. And then we'll graph the x-intercepts. The x-intercepts were, I'm just going to keep the scale the same. X scaled by 1. So this would be 2, 4, 6, 8, negative 2, negative 4, negative 6, negative 8. And our x-intercepts we saw were negative 2, 0, 2, 0, and negative 5, 0. So I label those negative 5, 0, negative 2, 0, and positive 2, 0. All right. Now, with our end behavior, going back up to here, the end behavior is the farthest most of your x-intercepts. I'm going to rise on the right, so the farthest to the right I'm going to rise, and my farthest to the left I'm going to fall. So I go over to my x-intercepts. Farthest on the right I'm going to rise, and farthest on the left I'm going to fall. Now remember, my shape has to look like a snake. So that means this is going to come up somehow, I'm going to come back down, and then it's going to connect, and then go back up. The only thing I really don't know is how high up that goes. So I'm just going to make an approximate. I'm going to evaluate it for like negative 3. Just so I can find out about how high that might go. So I say f of negative 3. And I substitute it right into this polynomial. So I say negative 3 cubed plus 5 times negative 3 squared minus 4 times negative 3, and then simplify this. So negative 3 times negative 3 times negative 3 is negative 27. Now we go to our power. Negative 3 times negative 3 is positive 9. Remember, we're doing orders of operations, PEMDAS, exponents first. Negative 27 plus 45 plus 12. So we just did our multiplication. Now we do our add and subtract. Negative 27 plus 45 plus 12 minus 20 is 10. So my ordered pair then is negative 3 up 10. Now I can graph that. Negative 3 up 10. So I'm just going to erase that little hill there. I thought it went up that high. I wasn't really sure. So negative 3, 10. Right about there. And there's my snake. So I'm just going to kind of highlight over again here in purple. And there is my cubic function graphed out to look like a shape of an S or a snake.